everyone. This is a video just to show you how to solve trigonometric equations. So first we're going to start with a basic trig equation. Here we have 8 sine theta minus 2 equals negative 6. So just like you would solve any equation when you're solving for the unknown, the variable, we are going to be solving for theta in this case. This one though is solving over an interval. So if you notice here we have 0 to 2 pi for our theta. So there is a restriction as to the number of solutions we will get given this equation. So let's first look at techniques that we know what we can do. So to both sides we're going to add 2. So we're going to have then 8 sine theta equals negative 4. Then we're going to divide both sides by 8 to then isolate for sine of theta. In this case is equal to negative 1/2. Now we've already talked a little bit about how the unit circle works and the different quadrants. So if we were to look at our quadrants, we know that sine is going to be negative in quadrant 3 and quadrant 4 because quadrants number 1 and 2, all of them are positive and sine is positive. So we know we should get solutions down here. The next thing we want to look at is, do we know the ratio? Now this can be done without a calculator. If you had a calculator, you could go sine inverse and then solve. But we can do this one without a calculator. If we look at the special triangles that we know of, there are 2. So we have the 45-degree angles, which is also pi over 4, and we'd like to keep in radians for this. We also have the pi over 6, pi over 3, which again is 30 and 60, and the ratios are 1 to root 3. So sine is always opposite over hypotenuse. Our hypotenuse is 2. The opposite one, in this case, we want it to be 1. So we're looking at a reference angle of pi over 6. So because we know it's in quadrants 3 and 4, now we need to consider how to get the other angles in the quadrant. Because right now we found a solution that is up here in quadrant 1, pi over 6. That's why it's our reference angle. So we know that there's going to be one down here and one down here. It's going to be this exact same little triangles. But how do you get to it? Well, we know this is pi. So we're going to have in quadrant 3, we're going to have pi plus your reference angle, which in this case is pi plus pi over 6, which will then give us 7 pi over 6. Again, set up equivalent fractions, and then you would find that value. In quadrant 4, it's going to be 2 pi minus the reference angle. So 2 pi minus your reference angle. In this case, again, 2 pi minus pi over 6, which will then give us 11 pi over 6. Now these give us two solutions that fall between 0 and 2 pi. So these would be our two possible solutions that fall in that range. Another type of equation that you might see is one that involves factoring. Again, we're going to look over an interval, so we're going to be looking between 0 and 2 pi. So if we move sine squared x and we move negative 2 sine x plus 1 equal to 0, we've basically set up a quadratic equation. We set it equal to 0, and that we know that if we factor something when it's set equal to 0, both of the two brackets, when multiplied together, one or both, has to be 0 for that to be true. So now we have to consider how to factor this. If it helps you with factoring, you can let sine of x be equal to some other variable. So then technically what we're looking at factoring is x squared minus 2x plus 1, which when we factor it, we'd have x minus 1, x minus 1. So as a result, we know that it's going to be sine of our little x minus 1 times by sine of our little x minus 1 equals 0. You do not need to show that step. If you can see the factoring without putting in a dummy variable, you can. It's just another way of looking at it. So then, now that we have this, we now know that this bracket is going to have to be equal to 0. Oh, sorry, minus 1 has to equal 0, as well as this one. They happen to be the same. So both of the two brackets would have their own equation, but in this case, they both are the same. So as a result, we can now continue to solve through and say sine of x has to equal to 1. Now this one uses a unit circle, And again, the coordinates go cosine sine. So here we have 1, 0. Here we have 0, 1. Here we have -1 and 0. And down here we have 0 and -1. So sine relates to the y variable. So we can see here that our solution here for x is going to be pi over 2. There is no other scenario that has a positive one, so there is only one solution for this particular case in this interval. Another type of problem you'll find is solving for all solutions. So this one here does not give you an interval in which to solve for. So we need to find all possible solutions. And because sine and cosine and tangent, they're periodic, therefore you're going to have a whole range of solutions based on adding the period to it. So again, we'll set up our equation. We're going to add 4 to both sides. 6 cos of theta is going to equal -3. And then cos of theta is equal to -3 over 6, which is equal to -1/2. So again, we will want to consider what quadrants that we want to work in. Cosine is negative, so we're looking at quadrants 2 and 3. But we're not just looking at quadrants 2 and 3. We're looking at all the cycles. So we would have one solution here to quadrant 2, one that would loop around to quadrant 2, and they'd all have the same terminal arm. So we have to consider adding 2 pi to every single solution that we get. We also need to consider our special triangles again, because we have a ratio of 1/2. So if we look at the pi over 6, that's 1, 2, and root 3, and pi over 3 here. And if we looked at the other one, the 45, 45, 90, or the pi over 4, that would be a 1, 1, root 2. In this case, again, we see it's a 1 over 2 scenario, and it's a -1 over 2, so therefore quadrants 2 and quadrants 3. And our reference angle that we would be looking at, cosine is adjacent over hypotenuse, so our reference angle is pi over 3. To find the particular solutions for the two different quadrants, we need to look at quadrant 2, which would be taking pi minus your reference angle. So you'd have pi minus pi over 3 in this case, which will then give you, again, if you have a common denominator, 2 pi over 3. In the third quadrant, you're looking at pi plus your reference angle, which will also again be pi plus pi over 3. And if you look at common denominators, you're looking at 4 pi over 3. So these are our particular solutions. And they are the ones that exist between the range of 0 and 2 pi. If we want to find the general solutions, which is what we need to get all of the solutions, we need to have 2 pi over 3 plus 2 pi. Now that would give me the next cycle, and then I'd have to add another 2 pi, which would give me the next cycle. And if I add another 2 pi, that would give me the next one. And even if I subtracted the next one. So I'm going to say 2 pi n. Now n is going to be an integer, which means it's a positive and negative whole number. So that way, that gets my negatives in there, and it also gives me every multiple of 2 pi that I would be adding to my particular solution. So that would be one solution. My second solution that I would want to look at is the 4 pi over 3, and the same thing falls there as well. I'm going to be adding 2 pi to get the next positive one, and another 2 pi to get the next positive angle. So ultimately, we're going to do the exact same thing. 2 pi n, n is an element of integers. Here's another example that we're going to use factoring for, but we're going to find all possible solutions again. So we are going to have to consider all the multiples that we are going to be adding or subtracting. So first we're going to look at the equation and figure out how to factor this. So I'm going to move everything over again and set it equal to 0. So if I go 2 tan x sine x plus 2 sine x minus tan x plus 1 equals 0. So at this point here, we need to figure out how does this work? Well, we're going to use some grouping. We can see there's a sine x in both of these and a 2 in both of these. So I'm going to just see if that will actually help me. So I'm going to use 2 sine x, and I'm going to do tan x plus 1 minus, oops, that should have been a negative over there. That should be a negative when I moved it over. Minus tan x minus 1. So now you can kind of see they both have a tan x plus 1 over here, and if I was to factor a negative out of both of these, I would then have the plus there. So this is factoring by grouping. It's the same group. There's technically an imaginary 1 there, so I can have 2 sine x minus 1 multiplied by tan x plus 1 is equal to 0. And as we showed before, we're going to set this bracket to equal 0 and this bracket to equal 0 and come up with our solutions based on those. So I will have here 2 sine of x minus 1 is going to equal 0. Therefore, sine of x is equal to 1 over 2. Here I will have tan of x plus 1 is equal to 0. Therefore, tan of x is equal to negative 1. So we're going to again look at how to solve these using the unit circle and the quadrants first. So sine is positive in this case. So if sine's positive, we're looking at quadrant 1 and quadrant 2 for this side. On this side, tangent is negative. So instead of being 1 and 3, we're looking at 2 and 4 because it's negative. The sine x, we're going to look at special triangles in unit circle again. It has a 1 to 2 ratio, so we are again looking at the special triangle of the 1 to root 3 with relationship to pi over 6 and pi over 3. Sine is opposite over hypotenuse, so my reference angle is going to be pi over 6. If I look at the tangent, we have a ratio of negative 1. So if we consider when we're going to get a 1 over 1 scenario, we really are looking at a special triangle of opposite over adjacent with a 1 to 1 ratio, which is our pi over 4 triangle. So now that we have that information, we can now move ahead with our reference angles. Oops, I didn't write that one down, pi over 4. And try to figure out what the particular solutions are. So here in quadrant 1 is just its reference angle. Quadrant 2 is going to be pi minus pi over 6, which is going to give me 5 pi over 6. Again, if you need a common denominator, 6 pi over 6 minus pi over 6. Here in this portion, we need a quadrant 2 solution and a quadrant 4 solution. Now the first one to get to it will be pi minus pi over 4, which will then give me 3 pi over 4. And if I look at quadrant 4, it would be 2 pi minus pi over 4, which will then, again, if you have common denominators, sorry, I didn't show you up there, 4 over 4, this will be 8 over 4, will be your 7 pi over 4. So now I have 4 particular solutions. So again, just like we were talking about before in the last example, I will have my pi over 6 plus all the rotations to get back to the next reference angle. So that would be my first particular general solution. This would be my second general solution where I have my 5 pi over 6 plus 2 pi n and in an integer. Now what's different here is these two are actually related. Tangent has some symmetry that goes with it, I guess after a period of pi instead of a period of 2 pi. And what I mean by that is if I was to add pi to this question or quadrant here, I will get quadrant 4. So you can write it as 2 equations, one for the 3 pi over 4 plus 2 pi n. That would get to the same quadrant because you're adding one whole rotation to get there. I could also write this one here, 7 pi over 4 plus 2 pi n, because then I would have the opposite quadrant and I would have the angle plus another whole rotation. But you can actually combine this into one because the period is actually smaller, and it is actually just pi n, because adding pi to this one will actually get me to this one down here. So you can write it in two different ways. So you could do it as 3 and 4, or you can have this as your general solution. They technically are all the same. Okay, hope that helps a little bit with understanding how you can solve quadratic and linear type trig equations. If you have any questions, let me know.